In this video, we are going to discuss about what is hysteresis. You know that in paramagnetic and diamagnetic substance, the magnetization M is directly proportional to the externally applied field. So M is equal to chi H, where chi is the magnetic susceptibility of the material. So if we see the relationship between magnetic induction and externally applied field H, it is also directly proportional to H. That is, B is directly proportional to H, B equal to mu H. So B and H are directly related, M and H are also directly proportional. So these materials, paramagnetic and diamagnetic, they are linear materials. But ferromagnetic materials, they do not have B and H has a linear relationship in ferromagnetism. So B and H is not linear in ferromagnets. This phenomena, this non-linear relationship between B and H, it is known as hysteresis. So hysteresis is a phenomena of lagging behind of the magnetic induction B behind the magnetizing field H of a ferromagnetic material when the material is at a temperature below its critical temperature. So this is known as hysteresis. Let us discuss the phenomena of hysteresis. Now we'll be discussing it step by step. Let us take a piece of ferromagnetic material and we magnetize it slowly. Now, as the magnetizing field H is increased due to the increase in current, at first the magnetic induction B begins to increase slowly, then more rapidly. At last, the magnetic induction gets saturated at a value of Bs along the path OA and becoming independent of H. This curve is known as the initial magnetization curve. Now here Hm represents the corresponding value of magnetizing field for which the magnetic induction reaches the saturated value. Now if H is decreased slowly, the magnetic induction decreases but does not follow the initial magnetization curve and lags behind the magnetizing field H. When H is decreased from Hm to 0, the magnetic induction B does not become 0, but it has a finite value Br at the point C. This OC represents the retentivity of the ferromagnetic material, and this retentivity is defined as the residual magnetism. So what is retentivity? The value of the magnetic induction which remains even when the magnetizing field in the material is reduced to 0 is called the retentivity of the substance. Now if the direction of the magnetizing field H is reversed and increased in negative direction, that is by reversing the current, the magnetic induction B further decreases and becomes 0 at the point D for the magnetizing field H equal to minus Hc. So this value of the reverse magnetizing field OD for which the residual magnetism becomes 0 is called the coercivity of the substance. So the coercivity is defined as the value of the reverse magnetizing field for which the residual magnetism becomes 0 is called the coercivity of the substance. If the magnetizing field H is now further increased in the negative direction, the magnetic induction B increases and reaches the saturated value in the reverse direction at the point E. On reversing and increasing the field again, the magnetic induction B follows the curve EFGA similar to ACDE, and it yields the negative retentivity minus Br and a positive coercivity plus Hc. As a result, a closed curve ACDEFGA is obtained for a complete cycle of magnetization. This closed BH curve is known as the hysteresis loop. In the next video, we'll discuss hysteresis loss.